Alright, review for Unit 4. Solve for x. What we want to do here is factor. So we have, since the second operator is positive and the first one is negative, then both are going to be negative. X times x gives me x squared. And 3 times 1 gives me positive 3. Multiply the inside just to double check this. That's negative 3x. Multiply the outside, you get a negative 1x. When you add that up, you get negative 4x. So we've guessed and we've checked. We've verified that this is the proper factorization. Now to solve for x, we use zero product property. X minus 3 is equal to 0, or x minus 1 is equal to 0. Add 3 to both sides. Add 1 to both sides. And so when we solve for x, x is equal to 1 or 3. Problem number 3. First we want to set this equation equal to 0. So we subtract 1 from both sides. Then we go ahead and factor. Since the second operator is negative, 1 is going to be plus and 1 is going to be minus. For 10x squared, we can either use 1 times 10 or 2 times 5. Since we're trying to get a negative 9 as our middle term, I'm going to go ahead and try 10x and x. 1 and 1. Multiply the inside, we get 1x. Multiply the outside, we get negative 10x. When we add that up, we get negative 9x. So this factorization is correct. So now we want to go ahead and use zero product property. 10x plus 1 is equal to 0, or x minus 1 is equal to 0. Go ahead and solve for x. Subtract 1 from both sides. Divide by 10. Subtract 1 from both sides, or actually add 1 to both sides. And so x is equal to negative 1/10, or positive 1. Number 5, what we want to do is set it equal to 0, so we subtract 5x from both sides. Then we do a greatest common factor, so we can factor out an x, and we're left with x times x minus 5 is equal to 0. Now we do zero product property. X is equal to 0, or x minus 5 is equal to 0. So when we solve for x is either equal to 0, or x is equal to positive 5. Number 7, we subtract 10x squared from both sides to set our equation equal to 0. Then we can see that there's a greatest common factor. We can pull out an x squared. So then we take these two parts, x squared, and we set it equal to 0, or x squared minus 10 is equal to 0. So we could take the square root of x squared is equal to 0, but in the end we're going to get x is equal to 0. Over here we add 10 to both sides. Then we take the square root. Whenever you take the square root of an equation, you got to add plus or minus. So x is equal to 0, or positive root 10, or negative root 10. You could also just say plus or minus root 10. Number 9, typically what we want to do here is a w substitution. So we want to let this variable w equal the binomial x plus 1. Substitute that in. So when we substitute w in, we get w squared plus 3 times w minus 10 is equal to 0. Now it looks a little bit easier to factor. So since the second operator is negative, one of them is plus and one of them is minus. W times w gives me w squared. And to get 10, we're going to use 5 and 2. So just double check. Multiply the inside, you get 5w. Multiply the outside, you get negative 2w. When you add that up, you get 3w, which is what we were looking for our middle term. So we factored it correctly. But before we use zero product property, we need to substitute the x plus 1 back in for the w. So we get x plus 1 plus 5 and x plus 1 minus 2. When we substitute x plus 1 back in, now we need to combine like terms. X plus 6 because 1 plus 5 is 6, and x minus 1 because 1 minus 2 is negative 1. Now we've completed our w substitution. We can go ahead and use zero product property. So x plus 6 is equal to 0, or x minus 1 is equal to 0. Solve for x, you get x is equal to negative 6 or x is equal to positive 1. And those are your answers for x. Number 10, the area of a rectangle is 2x squared plus 7x plus 6. If the width is x plus 2, find the length. There's no trick here. Really, it's asking you to factor the 2x squared plus 7x plus 6. It's telling you that one of those factors is going to be x plus 2. So since the second operator is positive, both of these are going to be plus. 2x times x is going to give me my 2x squared. And since I know one of these has to be x plus 2, obviously the second one has to be 2. And the only way to get 6 with the 2 is to use a 3. You can go ahead and double check the inside. The inside is 3x and the outside is 4x. When you add that up, you get that middle term, which is 7x. So we factored it correctly. So if the x plus 2 is our width, then that means that the 2x plus 3 must be our length. So the answer here is 2x plus 3. Give the axis of symmetry. What we need to recognize here is that this is vertex form. Vertex form is y is equal to a times x minus h squared plus k. And the axis of symmetry is equal to h. So here we need to recognize that this is the same as writing as 1/2 x minus 0 squared plus 6. When you see the x squared without an x, it's vertex form. So this 0 right here is my axis of symmetry. The axis of symmetry for problem number 13 is equal to 0. Number 15, find the axis of symmetry. Well, this is standard form. Standard form is y equals ax squared plus bx plus c. To find the axis of symmetry, there is a formula in standard form. You want to use negative b over 2a. So in this particular case, the a is equal to 1 because there's a 1 in front of the x squared. B is equal to 8 because that's the number in front of the x. And c is equal to 2. So we use these values and we plug it into our formula. Negative b over 2a is equal to negative 8 over 2 times 1, which is negative 8 over 2, which is equal to negative 4. So the axis of symmetry on number 15 in standard form using our formula is negative 4. Give the vertex and state whether it's a minimum or maximum. So what we need to recognize here that this is vertex form. There is a plus 0 out there that it's not written, but we need to understand is there. So this is of the form y is equal to a times x minus h squared plus k. So my vertex in vertex form is hk. In this particular case, I need to think opposite. The opposite of negative 2 is positive 2. So the x value of my vertex is positive 2, and the y value, which is k, is going to be 0. So the vertex of this particular equation is 2, 0. Now we need to state whether that there's a minimum or maximum. For minimum or maximum, we need to look at this value that's in front of the parentheses. That's called our a value. If a is positive, then that means our parabola opens up. If our parabola opens up, it means that we have a minimum. If our a value is negative, which in this case it is, it means that our parabola opens down. And if our parabola opens down, it means we have a maximum value. So in this particular equation, our vertex is 2, 0. And since our a value is equal to negative 6, it means that our parabola opens down. And we have a maximum value. Number 19, how does the 3 change the graph of y is equal to x plus 3 squared plus 1 from the original graph, y is equal to x squared? So the original graph is where we started, y equals x squared. What we need to recognize is that this is vertex form. It is x minus 0 squared plus 0. Those are equivalent. The a value is 1. There is a 1 in front of the x squared. So our original vertex of our first equation is 0, 0. The second equation that they gave us is y is equal to x plus 3 squared plus 1. The vertex of this particular equation is negative 3, positive 1, because we have to think opposite. So how does the 3 change the graph of y equals x plus 3 squared plus 1 from the original graph? Well, from the original graph, this 3 moves us left 3. So the 3 makes us move left 3 units. The 1 would make us move up 1 unit, but that's not what it asked for. It just asked for what the 3 did. Number 21, write the equation of the graph that results if the graph of y equals 1/2 x squared is translated to have the vertex of negative 2, negative 3. So let's go ahead and look at our first equation, y equals 1/2 x squared. We need to recognize that that is vertex form. Our a value is 1/2. There's a x minus 0 squared plus 0. So our vertex of this equation is at 0, 0. And if we were going to translate this vertex to negative 2, negative 3, the equation would then become y is equal to 1/2. We have to think opposite. So because this is a negative 2, inside the parentheses we would want to put a positive 2. And then our k value, which is negative 3, would go as negative 3 on the outside. So if we took our original graph and translated it to a vertex of negative 2, negative 3, our new equation would be y equals 1/2 x plus 2, because we think opposite for the x value, minus 3. Give the x-intercepts if they exist. So if we're trying to find the x-intercepts, then that means we want to let the y value equal 0, and then we want to solve for x. So we'll go ahead and do that. We're going to let y equal 0, which means 0 is equal to 2 times x plus 1 squared minus 8. Then we want to go ahead and do what we need to do to solve for this. So we would first add x to both sides, or add 8 to both sides, excuse me. When we do that, we would get 8 is equal to 2 times x plus 1 squared. Now we would go ahead and divide both sides by 2. So 4 is equal to x plus 1 squared. Now we can take the square root of both sides of the equation. When we do that, we'll get x plus 1 equals, make sure you add a plus or minus, because that's important when you take a square root of an equation. It's going to be plus or minus the square root of 4. So that's going to be plus or minus 2, because the square root of 4 is 2. Now we'd want to subtract 1 from both sides, so we'd have negative 1 plus or minus 2. Now we're not completely done yet. We need to split, because this is the same as saying x is equal to negative 1 plus 2, or x is equal to negative 1 minus 2. We would go ahead and combine like terms. X is equal to 1, or x is equal to negative 3. So the x-intercepts would be 1, 0, and negative 3, 0. Number 25, give the x-intercepts if they exist. So again, we want to let y equals 0, and then solve for x. We would subtract 7 from both sides. We get negative 7 is equal to x squared. Then we would take the square root of the equation. So we would get x is equal to plus or minus the square root of negative 7. Anytime we have a negative under a radical, we want to factor out an I. So this is going to be plus or minus I root 7 is equal to x. And because our answer has an I in it, that means that we do not have x-intercepts that exist. So the x-intercepts on this particular equation does not exist, because anything that has an I in it is a complex number, which means it's not a real number that we can graph on a coordinate plane. Give the x-intercepts if they exist. So again, on number 27, we want to let y equal 0, and then solve for x. So we subtract 12 from both sides. we divide both sides by 4. Then we go ahead and take the square root. When we take the square root, we got to make sure we add plus or minus. And again, we end up with the same situation where we get plus or minus I root 3 is equal to x. And because this is not a real number, these x-intercepts do not exist. So does not exist. Find the y-intercept, or give the y-intercept. Well, this is vertex form. Which, excuse me, doesn't really matter. To find the y-intercept, we want to let x equal 0. When we let x equal 0, we want to solve for y. So when we do that, we get y is equal to 2 times 0 plus 1 squared minus 8. Then we would go ahead and do our parentheses first. So y is equal to 2 times 1 squared minus 8. 1 squared is 1, so this is y equals 2 minus 8. So y equals negative 6. So our y-intercept is going to be 0, negative 6. Remember, we let x equal 0, so that is why when we write our ordered pair, the x coordinate is 0.